This video will briefly touch on some of the stuff you're going to see in Chapter 2. Chapter 2 deals first off with limits. And that is what value does the function take on as we approach a given value of x. Right. So let's look at this in terms, what's what we mean by this in terms of, first off, a graph. Put some marks in here and let's draw my graph. And so we want a point there, want an open one here, and then we're going to go, and then I want an open point here, and we're going to go up like this. All right. So I have my graph of my function. It is a function. It is continuous over the interval. And so we can talk in terms of limits. And so we can talk, first off, let's do in terms of one-sided limits. So for example, I want to know what is the limit of f of x as x approaches 1, but from numbers that are less than 1, right? So we're going to be getting closer and closer to 1 on the x-axis, but we're coming in basically from the left side. So what that would mean on this graph is that we're coming in on this direction, right? Which means we're going to be on this red curve here that is going up like this. And so as we get closer and closer to 1, my function is approaching the answer of 4. Right? And then if we do what is the limit of f of x as x approaches 1, but this time from numbers that are greater than 1. So now we're coming in this direction, which means we're now on this curve, and my function appears to be closing in on -2. Okay. Right. Well, then we could say, okay, well, what is the limit of f of x as x approaches 1? Right? Well, the thing here, in order for it to have an answer, I have to be approaching the same number from either direction. So we see that if I do 1 from numbers that are less than 1, I go to 4. If I do numbers that are greater than 1, I go to 2. And so here, this one, the answer would be does not exist. Because after all, we approach 2 different values. Right? Well, what if I ask this one? What is the limit of f of x as x approaches -3, right? Well, we can see on my graph that if I come in this way, I go here. If I come in this way, I go here. And both of them are heading towards the same value, and that value is 0. So limits. So again, in terms of getting the limits, so we could do, if we have something like this, limit as x approaches 3 of x squared plus 2x minus 7. Well, we could just plug in the number. And so we would have 3 squared plus 2 times 3 minus 7. and we get to 8. And then if I have one like this, what is the limit as x approaches 4? And we have x squared. We want minus x plus 12 over, right? So in the previous one, we said I could just plug in the number, because after all, I'm not going to violate any rules like by dividing by 0 or anything. But in the bottom one, the next one, we see that if I plug in 4 everywhere, well, the bottom term would go to 0, and that's going to create a problem. But in the case of this one, however, the top can be factored. This will give me x minus 4, x plus 3. And now the problem terms would go away. And now I can evaluate this, and I get an answer of what would be 4 plus 3, which will be 7. So now we can get rid of the problem term and then plug in. Right? Let's do another one here. So let's say I have this. What is the limit as x goes to 3? X minus 3 over x squared. Well, this would be 3 minus 3 over 3 squared. So 0 over 9, which will be 0. So limits. Other things you'll see in this chapter is what is called the difference quotient. And so the limit as h goes to 0, f of x plus h minus f of x over h. And so, for example, if I had that f of x is equal to x squared plus 2x minus 3, we then need to know what is the f of x plus h. So everywhere we see the x, we're going to plug in the x plus h. So this will be x plus h squared 2 times x plus h minus 3. And so this will give us x squared plus 2hx plus h squared plus 2x plus 2h minus 3. Now we can take our pieces and plug them into that definition. So we want the limit as h goes to 0. And so we're going to have x squared plus 2hx plus h squared plus 2x plus 2h minus 3 minus the f of x part, which was the x squared, plus 2x minus 3 all over h. And now we can do some canceling. So we get an x squared minus x squared, 2x minus a 2x, minus 3 minus a minus 3. So all of those go away. And we're left with 2hx plus h squared plus 2h over h. And again, still taking the limit. But now if I look at the top, I can take an h out of everything. So h comes out. So we get a 2x plus h plus 2 over h. And so now the h's go away. And now we want the limit of that as h goes to 0. And so this would give us 2x plus 0 plus 2, which of course would just be 2x plus 2. And we now we're going to have limits that go to infinity. So, for example, what is the limit? X goes to 1 on the positive side, 1 over x minus 1. Well, that's going to equal to infinity. And then if I ask what is the limit as x goes to 1 for numbers that are less than 1, we'll find out that this will give us negative infinity. And what if I had something like this? What is the limit as x goes to 2 for x over... Well, I can't plug in the number and get an answer because after all, the bottom term goes to 0, but we could make a chart. And so we're going to first start with numbers that are less than 2. So 1.9, 1.99, 1.999. And then we would plug those numbers in and get our answers. So this comes out, the first one, negative 76, negative 796, and then negative 7996. We then make another chart with numbers that are bigger than 2, so 2.1, 2.01, and 2.001. And so here we end up with 84, 804, and then 8,004. So we can see from our chart that when we come in from numbers that are less than 2, we're heading towards negative infinity. We come in from numbers that are bigger than 2, we're heading towards positive infinity. And so in this case, this one, the limit does not exist, right? So functions. So functions have to be continuous. Which basically means there cannot be any breaks in my function. So, for example, if I had something like this, this would be a function, right? But if I had a graph that looked like this, so now you get one that goes up like this and goes down like this. This one is not continuous. It has a break in it, right? So functions have to be continuous, right? So those places where there are breaks are in terms of what are called partition numbers. So for example, if I had f of x equals x squared over x squared minus x minus 42. Right? Well, the bottom thing is a trinomial. It happens that that thing could be factored, and so this gives me x minus 7, x plus 6. And so other numbers would make that equal to 0. So x minus 7 times x plus 6 equals 0. Well, either x minus 7 could equal 0, or the x plus 6 could equal 0. So here I get, this would be 7, and this would be negative 6. So we got those would be what are called my partition numbers, right? So what happens to my function then? So let's look at what would happen here. So we're going to make a little chart. So we're going to put in, this is going to be negative 6. And this is going to be 7. And we have our x squared function here. And then we're dividing by the x plus 6, x minus 7. Right? So what we're going to do is sort of figure out what is the sign of my function as we go through these various parts. So this is going to be f of x. Right? 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 So if x is less than -6, well, x squared will be positive, because after all, it's squaring, so it's always going to be positive. This number will be negative, and x minus 7 will be negative. Right? So a negative times a negative is a positive, and a positive divided by a positive is a positive. Right? And this will be positive. X plus 6, and if a number is greater than -6, this is now positive, but this is negative. So my bottom term will be negative, and a positive divided by a negative will be a negative. There will be one exception. If you notice, there will be an exception at 0. It will touch at 0. And then lastly, for greater than 7, well, this will be positive. This will be positive, this will be positive, and so the result will be a positive number. Right? Right. So then you get to what is called the derivative. And the derivative is basically that what we just looked at. And that is, what is the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay. So if you look at the one we just did over here previously, we did that when we did this part here. We basically found the derivative of that function. Right? We call the difference quotient. Now that is actually what we also call the derivative. Right? So let's do another one, how this would work. So we have f of x equals 2x squared minus 4x plus 3. So then we need to know the f of x plus h, which is going to be 2 times x plus h squared minus 4 times x plus h plus 3. And so this will give us 2x squared plus 4hx plus 2h squared minus 4x minus 4h plus 3. And now we can plug that in. And so we want the limit as h goes to 0. So we have 2x squared plus 4hx plus 2h squared minus 4x minus 4h plus 3. All of this minus the original f of x, which is 2x squared minus 4x plus 3. All of that divided by h. And then again, we can do some canceling. So 2x squared, 4x, 4x, and the 3, and the 3. So that leaves us 4hx plus 2h squared minus 4h over h. And then we could factor the h out. H 4x plus 2h minus 4 over h. Of course, now these go away. And so now we want the limit as h goes to 0 of 4x plus 2h minus 4, and that'll give us 4x minus 4. So we found our derivative. Right? So in terms of notation and how you'll see that represented when I want to find the derivative, so we have f of x, which is my original function. So my derivative then is going to be f prime x, or y prime is another way you'll see it, over dy over dx, or the derivative with respect to x of f of x. So those are the different types of notation we can use for doing this. All right. So we want to find, let's find derivatives. And then the other thing here is that a derivative of a constant is 0. So basically what derivative is basically is slope. What is the rate of change? And of course, a constant doesn't change. So that's why that's 0. And so first basic rule of finding derivatives. So if I have f of x equals ax to the n, then my derivative is going to be a times n x to the n minus 1. Okay. So my first basic rule. So if I had f of x equals 2x minus 7x squared, and I want to find my derivative. Okay. So f prime x is going to be 2 minus 14x. Right? And let's say I have this one. F of x equals 7x cubed, 14x squared, the square root of x. Well, the first thing I want to do is rewrite this and get rid of the radical. And so square root is the same thing as x to the 1/2. And so I get that. Now I can do my derivative. So this is 21x squared minus 28x plus 1/2 x to the minus 1/2. And then the derivative of a constant is 0. And then the next thing deals with what are called differentials. So let's say y equals 4x squared plus 6x plus 2. And so my derivative dy dx is going to equal 8x plus 6. That's my derivative. And the differential, basically there's just one more step, and the new step is now that dy is going to equal 8x plus 6 times dx. And so that's only the new step, is I brought that dx over to the other side. And then the last sections of that chapter deal with how does all this apply to business. So application to business. So you get, in terms of various functions, so total cost, which is going to be given by Cx, marginal cost, which is given by the derivative of the cost function. And then we have total revenue, which is going to be given by R of x. Right? And then we can have marginal revenue, which is going to be the derivative of r of x. And then we can have profit. And so the profit function is going to be the revenue minus the cost. And then we can have our marginal profit, which is going to be my derivative, which is going to be the derivative of r of x minus the derivative of c. So we got those. So let's do a little example then dealing with this. So if I say that the cost function is given by 145 plus 1.1x, and the revenue function is given by 5x minus 0.02x squared. Okay. Well, the derivative here is going to be 1.1, and my derivative over here would be 5 minus 0.04x. And we can write our profit function. So the profit function, p of x, is going to be the revenue, which was 5x minus 0.02x squared. This part minus the 145 plus 1.1x. And we could rewrite this. This will become 3.9x minus 0.02x squared minus 145. And then, of course, we could take the derivative of that. And so this is going to give me 3.9 minus 0.04x. Let's see. Other terms you'll see in this is what is called the break-even point. So the break-even point happens when the revenue is equal to the cost. So in terms of my example, what would be the break-even points for this? And so we had a revenue function, which was 5x minus 0.02x squared equals 145 plus 1.1x. It is a quadratic, and so we want to set that equal to 0. So I'm going to subtract the 5x and add the 0.02x squared, subtract the 5x, and add the 0.02x squared. And so we get 0 is going to equal 0.02x squared minus 3.9x plus 145. And we want to find x. Again, it's quadratic. And so one of the ways of finding that was using the whole quadratic formula. And so remember that was x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So here a is 0.02, b is negative 3.9, and c is 145. So we take our numbers, we plug them in. So this is 3.9 plus or minus a negative 3.9 squared minus 4 times 0.02 times 145 all over 2 times 0.02, right? Then it's a matter of number crunching. So this becomes 3.9 plus or minus the square root of 3.61 over 0.04. So 3.9 plus or minus 1.9 over 0.04. And so now we get 3.9 plus 1.9 over 0.4. So this is going to be 0.04 rather. And we correct that. Sorry. That should be 0.04. 0.04. So this is going to be 5.8 divided by 0.04, which is going to give us 145. And then the other answer would be 3.9 minus 1.9 over 0.04. So this is going to be 2 divided by 0.04. And this will give us 50. Right? So in this case, there are two break-even points, right, for this one. Right? One is at 50, the other is at 145. So anywhere between 50 and 145, they're making money. Right? Outside of that, they would be losing money in this example. And that will conclude this video.